My name is MD Rizal Korim. I'm going to present my project, Multitask Symptom Graph Attention Network for Ordinal Prediction of Mental Health. Initially, I installed some of the important libraries and frameworks that required for the implementation of my project. Here are some essential imports uh, for extract different functions from the frameworks. And this is the Google Drive mount so that I can connect the code with the Google Drive. And here I classify different type of features and the outputs that will be used for create the graph, initial graph. Some operation like leakage, removing leakage column, clean data, and code ordinal levels, so assigning a value for each type of output classes as it's in this type of format in the dataset, and then finally prepare the modified dataset. Here is some EDA, how we can identify some key pattern and factors of features that are responsible for the uh, our prediction. We conduct EDA. We next phase is to construct the data set. So here is the code where we constructed the initial symptom graph using graphical lasso, and after that we got and here is the code for visualizing graphs, so we can see the whole graph is there and how different nodes are connected to each other. So it's an abstract visualization of the graph. And initially is to create a meshed matrix for creating the graph, and here's the matrix. There's some features, and here is the train test split. So test size is 0.2. That means we used 80% of the data for training purpose. So here is the train and test size. That data is very limited and it's a highly imbalanced data set, and we prepare the data set into the graph data structure. So it's very important phase, and then we build the train and test data set from the graph. And here is the model definition. These are some input output classes and some hyperparameters. Here is the first layer of the proposed method. This is the second layer, and these are some output heads where we use sequential network. That means it's stacked, all of the levels are stacked to each other, and and here is the overall stack. uh, Initially gate 1, then exponential linear unit for strict and more efficient activation of each layers. So here is the graph definition. Here is we just outputted the graph. Here it's the same thing, and this is the training function, how we train the over function in for one epoch. So we have to explicitly define all of the things as it's a graph neural network. And here is the evaluation. We defined different type of evaluation metrics that would needed for identify and define the robustness and efficiency of the proposed method. And this is the train model section where we define how many epochs, and in the history what would be stored in the history, as history will be further used for different plot and other. And this is how we can present each epoch's results during runtime. So here we can see different epochs, exactly how we prepare the output. And here is the plot of the output. So here is MAE on different epochs, and here is the on a result table on test dataset, and here are some outputs. These are some confusion metrics. So this codes is for confusion metrics and output results of the model. And here is some feature importance. So from this point, these codes are for explainable artificial intelligence. This is explainable symptom graph. So based on the overall training, which features are most influential for the overall prediction. And here is like symptom important graphs and so on. So here is the brief code I prepared. So I have, this is a very large project. All of the things were very tough to make comprehensive within a short video. Thanks for watching.